Today's lesson is on multiplying binomials. A binomial term is the sum of two monomial terms. There are several ways to multiply binomials. We'll look at three ways today. One's the distributive method, the other is FOIL, and the last one is the geometric method, where we're going to use areas of rectangles to find the product. All right, for example, using the distributive method, if I want to multiply 2x plus 3 times x plus 3, I go from left to right. I'm going to use the first term from the first binomial. I'll put 2x, and I'm going to multiply it times x plus 3, the binomial to the right. Then I have an addition sign there, so the addition sign goes here. The second term from the first binomial is 3. So I'm going to distribute that again to x plus 3, the binomial on the right. So I'm going to go ahead and distribute that. That's 2x times x and 2x times 3. So that gives you 2x squared plus 6x. Plus sign stays. I'm going to distribute these two. So I get 3x plus 9. And now I just simply add like terms. 2x squared, there's no other 2x squareds in the expression, so you leave that 2x squared. I have a 6x, I have a 3x, so I can combine those. 6 plus 3 is 9. Do not change the exponents, just 9x, not 9x squared, just 9x. One constant, so that's going to be 9. That's as far as you can go, because these are unlike terms. So you have 2x squared plus 9x plus 9 is the product. All right, another method is called the FOIL method. And we're going to use the same binomials. We have 2x plus 3, x plus 3. But we're going to use the FOIL method. FOIL represents first, outer, inner, and last. It's just a method of multiplying two binomials. So the first term is 2x and x. So I'll say 2x times x. And the outer term is 2x and 3. So we'll put 2x times 3. The inner term is 3 times x. And my last term is 3 times 3. All right, so you're going to multiply those. So I get 2x squared, 6x, 3x, 9. And you just add up all the like terms. I have 2x squared, but there's no other x squared, so that stays like it is. I can add 6 and 3. That's going to be 9, 9x, because those are like terms, and 9. And that's the product of 2x plus 3 times x plus 3. And another method is called the geometric method, where we're going to use rectangles. And we're going to get the area of each rectangle. So let's say I start with 2x plus 3. I can put 2x, and I put a 3 down there. X and 3. So this becomes a x by 2x rectangle. Remember, the area of every rectangle is length times width. So 2x times x is 2x squared. And opposite sides of rectangles are always the same length. So from here to here is x, from here to here is x. So x times 3 is 3x. I have 3 times 2x. That gives me 6x. And 3 times 3 is 9. And you just simply add the like terms, which is always in the diagonal. So you got 2x squared plus 9x plus 9. All right, I have two binomials. You can use any method on this. I have x plus 3 times x plus 5. But one quick way to do this is to notice a pattern. The middle term is always going to add up to the two constants, and the last term is always going to be the product of the two constants. We know that x times x is always x squared. So I'm going to say, well, 3 plus 5 is 8. So I'm going to put 8x. That tells me my coefficient. And the last term is 3 times 5 is 15. Easy to get the product just with that. This only works when the coefficient is 1. Or something like this, you might have to either use distributive or FOIL or the geometric method. Let's say I use the geometric method. So I have 2x and 2, x and 5. 2x times x is 2x squared, 2x squared. And 2 times x is 2x. 2x times 5 is 10x. And 2 times 5 is 10. And you add the like terms. So you got 2x squared plus 12x plus 10. And that's your product. All right, and you can do the same thing with this. I have 3x, 2, 2x, and 3. Well, 3x times 2x is 6x squared. 2x times 2 is 4x. 3 times 3x is 9x. And 3 times 2 is 6. And just add up each of these areas. 6x squared, and I can add the 4x to the 9x because they're like terms. That'll be 13x, and then plus 6. All right, multiply 3x minus 2 times 3x plus 2. If you notice, there's a pattern here. We have the exact same terms, but opposite signs. I got 3x, 3x, 2, 2, but I have a subtraction here and addition here. When you see that, that's called the difference of squares. And what that states is when you have the same term in the binomial but opposite signs, it's just simply the difference of the squares of those two terms. So all I got to do is take 3x and square it. The subtraction stays. And then I'm going to take 2 and square it. And I'm done. You can use the other methods, the FOIL method and distributive, and you'll see that the middle term will cancel out. You save a lot of time if you know this pattern. So this is going to be 9 squared, 9x squared, minus, and 2 squared is just simply 4. So 9x squared minus 4 is the product. All right, multiply. There's a pattern on this too. Notice that this is the exact same term. I got x minus 6, x minus 6. This is just simply a square. So put x squared. If I were to add 6, negative 6, and negative 6, I'm going to get negative 12. That's going to be my coefficient for the linear term. But if I multiply negative 6 times negative 6, I'm going to get a plus 36. This will help you in factoring if you know the pattern. Notice that when you multiply two binomials where the signs are the same, if it's positive, you're going to have a plus plus. If they're both negative, you're going to be minus plus, always. This concludes our lesson for today.